Hey guys, today we are continuing talking about graphing polynomials, but today we're going to get just a slight bit more specific in the sense that we're not just going to have ones that are already factored for us, we're going to factor some for ourselves. So first off, let's remind ourselves about the end behavior of polynomials. So for instance, if we have a even degree and a positive leading coefficient, so that would be like x squared, x to the fourth, x to the sixth, so on and so forth. That would be both opening together and both opening up. If those were instead negative, like negative x squared, or negative x to the fourth, or negative x to the sixth, it would still be opening in the same direction, but it would be opening downwards. Odd degrees, like x, x cubed, x to the fifth, and so on, those open in opposite directions. And if it's positive, it goes from the bottom left to the top right, like this one does. And if it's negative, it's going to open from the top left to the bottom right. Okay? So let's go back through our steps to be able to graph these out. First and foremost, factor and find the roots. Sometimes it's factored for us already. Sometimes we have to do the factoring. Number two, plot the roots. So put your points on your graph. Don't worry about labeling the y-axis or getting too specific with that. We're really focused on the roots. Third, draw the end behavior. And then fourth, just connect the dots. So let's give this a shot on number one right here. Okay, so number one, first step, we need to factor. We need to factor to find my roots, to find where it intercepts my axis at. So this one, we check and see how many, do I have a GCF? How many terms do I have? And that's going to show me how to factor. So first, do I have a GCF? No. On number one here, we have no GCF. Second, factor by grouping, because this is four terms, or as I like to call it, double GCF. Grouping, we're going to group the first two together, the last two together. So if I group the first two together, these two have a x squared in common. So I can pull out an x squared. I'm going to get x squared times x plus 3. Then we have negative x minus 3. So what do these two have in common? Well, nothing really, except my first one is negative. And I don't want it to be negative, so I'm going to pull out a negative 1 out of both of these. So we're going to have a negative 1 in front times negative x divided by negative 1 is a positive x. Negative 3 divided by negative 1 is a positive 3. So we have these two in common. We can pull that out to the front. We have x plus 3 times x squared minus 1. Now, we're not done factoring quite yet. That x squared minus 1 can still factor a wee bit more. So we're going to take that x squared minus 1. That is a difference of squares. Remember, when we have a difference of squares, it's going to be a plus b times a minus b, where a and b are the square roots of our perfect squares. So our square root of x squared is x. We can build our little parentheses. I'm going to have x plus 1 times x minus 1. Okay? So there are all my factors. We have x plus 3. Sorry, my bad. We have x plus 3, x plus 1, and x minus 1. Now, if I set each one of these equal to 0, we would be able to find my solutions or my roots, or where they intersect the x-axis. So for this one, if I set x plus 3 equals 0, we would get if we went x plus 3 equals 0, we would get a root at x equals negative 3. Same thing for x plus 1, we get x equals negative 1. And x minus 1, we would get x equals 1. So here are my roots. X equals negative 3, negative 1, and 1. We can put those points on my graph over here. Have a point at negative 1, 2, 3. Have a point at negative 1. Have a point at positive 1. Okay, now we need to think about our ends. Well, we can look at this one of two ways. We can look at the highest degree on my equation. That's x cubed. X cubed is my highest degree. We can think, okay, and here I have 1, 2, 3 x's timed together, so that gives me x to the third 2. It's going to be positive, and since it's x cubed, it's going to be opposite direction. Because remember, cubed or any odd degree means that we're going to go in opposite directions. And since it's positive, we're going to go down to the left and up to the right. If you need to refresh yourself on that, just look back at our chart here, and that'll tell you where your graph is going to go. All right, so now I just need to, if we're going down to the left and up to the right, now I just need to connect the dots. Through, and through. And there is my graph for number 1. All right, let's take a look at number 2. So number 2, I need to factor as well. So first step in this factoring is deciding how to factor it, and if there is a GCF. So we're going to look here and we're going to say, okay, is there a GCF? And on this one, yes, there is a GCF. And my GCF is going to be x squared. So we're going to go in here, we're going to divide the first one by x squared, this one by x squared, and this one by x squared. So we'll have x squared in front times x squared plus 6x plus 9. Okay, look back at that flow chart if you need to. But here on this one, we have 3 terms. And if we have 3 terms, we can factor using our old way of factoring, the x and plus, right? So we can draw an x and a plus. We can label my a, my b, and my c. This can be my a is going to be 1, my b is going to be 6, my b is going to be 6, my c is going to be 9. So we're going to have 9 on top, 6 on bottom, so this one's pretty easy. It's just going to be 3 times 3. So remember, these two numbers multiply the top and add to the bottom. So 3 times 3 is 9, 3 plus 3 is 6. So here are my 2 factors. We have x plus 3, and x squared. Okay, so I want you to notice something. We could also write that as x plus 3 squared. So I really just have 2 factors. We have an x squared and an x plus 3 squared. Remember, if they are squared, though, we call these a double root, and double roots bounce. Okay? Remember from yesterday's lesson, double roots bounce. So we could write this x squared equals 0, x plus 3 equals 0. Both of these are going to be double roots. So we're going to get x equals 0 and x equals negative 3. Now remember, both of these are double roots. Okay? So whenever we draw these on here, we know they're going to bounce. Okay, let's talk about my endpoints. Well, let's go ahead and draw these on here. We're going to have one at 0 and one at negative 1, 2, 3. All right, my endpoints. Well, we look back at our beginning, we have the highest degree of x to the 4th, which makes sense because we have x squared times x plus 3 squared gives me x to the 4th as well. So we have x to the 4th, so that means they're going to go the same direction, and they're going to be positive. Okay, same direction positive, so they're going to open up and up like that. So we know on my graph, we're going to end up going this way and this way. It's going to bounce off of these because double roots bounce. So it's going to go like this, like that. It's going to bounce off the line and go back up. Okay? All right, let's turn the page. Let's take a look at number 3. So number 3, we have 3x to the 5th minus 48x cubed. So once again, first step, we look for a GCF. And in this case, my GCF is going to be, let's see here, we can pull out a GCF of 3x cubed. So we can divide this first one by 3x cubed, divide this one by 3x cubed, and we're going to get 3x cubed in front equals x squared minus 16. Not equals, sorry, times x squared minus 16. So we're going to go times x squared minus 16. X squared minus 16 is a perfect square. So just like we did on the first page, we're going to build my parentheses and go a plus b, a minus b, where a and b are the square roots. The square root of x squared is x. The square root of 16 is 4. So we're going to go x plus 4 times x minus 4. Okay, take each one of these, set them equal to 0. So 3x cubed equals 0, x plus 4 equals 0, and x minus 4 equals 0. So if we do 3x cubed equals 0, we're just going to get x equals 0. If we do, because if we divide by 3 and cube root, 0 is not going to change. If I minus 4 here, we get x equals negative 4. If I add 4 here, we get x equals positive 4. So those are my intercepts. We have x equals 0, negative 4, and 4. Now there's something special about this guy right here. It is a triple root, which means we're going to have that little kink in the line right there. Okay, so let's go ahead and draw our points on here. We're going to have one at 0, one at negative 1, 2, 3, 4, one at positive 1, 2, 3, 4. My endpoints. Well, my highest degree is to the 5th, and it is positive. My leading coefficient is positive, so we're going to have an x to the 5th. And so that means that if it's positive and opposite directions, it's going to open up like this and down like that. So whenever I draw my graph on here, we know we're going to go here and here. We know this 0 is a triple root, so don't forget that. So it's going to go up through here, back down. It's going to have this little kink in it. It's going to go back up that direction. All right? So the hardest part about this is factoring. Being able to graph it, I hope, is pretty straightforward. All right. Now, let's take a look at number 4 and 5. This is where we start with the graph that it gives us, and we write our equation for it. Well, guys, it's pretty straightforward. It's pretty easy. So what we're going to do is we're going to find my zeros first. So we have 1, 2, 3, and 4. So we're going to have a 0 at negative 1, negative 2, negative 3, and positive 1. Okay? My ends, they're both going up. So we know it's going to be even, and we know that it's going to be the same and positive. All right, so now when I write my polynomial out, it's going to look like this. We're going to go y equals, then we're going to take each one of these, we're going to build the parentheses for it, but it's going to be opposite, right? So for x minus 1, we're going to have an x plus 1, because we'd have to set it equal to 0 to get to my 0. All right, then we're going to go x plus 2, x plus 3, and x minus 1. These would create all of my zeros. Then we're going to check, okay, it's positive, good, it's positive. It's even, yeah, x times x times x times x, that gives me x to the 4th. So this is our correct graph. All right, now let's see what number 5. Okay, so number 5, first off, find the x-intercepts. So my x-intercepts, we're going to have 1 at negative 3, 1 at negative 2, and then 1 at positive 1. Now, we need to take note of a couple things. First off, this is a double root, right? So that means x, that negative 2 right here is a double root. All right, what about 1? 1 is a triple root, right? Because it has that kink in it. So we know this 1 is going to be a triple root. All right, so my ends, they're both the same, and they are negative. So cannot forget about that negative, so we know that it's going to be negative x to the even. All right, so now we can write out our polynomial. We can go y equals x plus 3 to get that negative 3, x plus 2 squared to take care of that negative 2 right there, and it needs to be squared because it's double root. And then last one, x minus 1 cubed to make that triple root. Now I'm forgetting something, and that is that this is negative. They're both going down. So I'm going to put a negative symbol in front, okay, to make my whole graph negative. All right, guys, hopefully that clears up some questions you may have on graphing and factoring. Okay, if you have any other questions, though, please be sure to let me know. All right, thanks, guys.